Hello, hello. So this would be a very quick, short, unscripted video. I didn't actually even plan on doing this until literally a couple seconds ago, but I think it's a pretty simple topic for me to kind of go over at a high level. There's definitely way more we could get into with this. We could connect this back to state T, and actually, when I learned about random, that was how I learned, about random. I learned it through state. Uh, and the reason for that is really to summarize it really quickly, that there's no such thing as random with computer. Or you could actually find tricks to sort of create a random-ish variable, but the true thing that we are doing is we're generating pseudo random numbers. And so how that actually works in terms of how computers manage that is they look at what the last number was that was generated pseudo randomly, and then uses that to determine what the next number is. At least it's my understanding, and if my understanding is correct, which I haven't looked into this for a while, but again, just trying to do this very quickly, um, then you know, basically, if we get four, we should. Yes, this is definitely true with Haskell for sure. Um, don't know about other languages where there's impurities, which probably would have more randomness by default. Um, but with a pure language like Haskell, if we just generated four as a random number, and we keep the state of what generated that four, like we keep the seed, I believe it's called, and then generate based off of the last seed representing effectively four, then if that gives us, let's say, 200,017, then it will always jump from 4 to 2017 or 200,017. Um, and likewise for the entire length of the list of random or pseudo random numbers. Um, and so, you can represent that, implement that in any language in any way. You could even literally just have a list of, fake random numbers that you generate. Other tricks I've seen, or heard of rather, are just simply, taking the heat of your processor at the point in time, which is random in a sense that there's so many different things that could affect it, and it would vary along some range. And so they take the heat of the relative heat of the processor, or whatever part they are measuring. I believe it's the processor, and then use this to create some random number. So the only function I'm going to actually now describe here is randomRIO. And randomRIO is the simplest way to use the System.Random um, module from the random package. Um, and it's really simple. If we look at the type of randomRIO, we see that it takes an A, or a tuple of A and A, and gives us back um, a monad IOA. So really, for example, this could be a monad transformer stack just because of how it's written. We don't actually it doesn't necessarily need to define random RIO doesn't necessarily have to have this constraint. Like you could in theory just write it to force it to use IO, and then with any monad transformer stack we just call lift IO, random RIO. But I suppose here they've done that for convenience. And so I'm just going to say that this is basically IO. And so what we're doing here is we are giving it a range from A to B, if you will, and it's going to return us some random in that, in our output. And so, like, you may be wondering, too, like, maybe you could kind of guess with the previous, explanation about, heat on a computer being what creates some random variable generations. But why do we need I/O here? And the reason for that, again, comes back to the purity aspect. If we had something like this, then it would literally be impossible to actually create a random number. And the reason for that is, I believe in the background, I haven't looked into this, I don't really care. Just want to do this very quickly again. Um, but there are a lot more resources. Like look at the module, and the module actually gives a great explanation about how random numbers work in Haskell, which I do recommend. But if effectively, I believe that somewhere we are keeping track of this random seed we are using to generate a pseudo-random number, and so that's why we don't have to keep track of the seed, because it's implicitly being taken care of by the Haskell runtime. And now we could do that, and that's where the random gets a little bit more complicated. But I kind of check out at that point. I don't think it's worth even thinking about. There's performance benefits for sure, but I just don't care. Um, so yeah. So let's actually try this out. And there's another type class here that we are using, and it's defined, of course, by the random package that we have this random type class. And so if we look at the info for random, we see that it has a number of different types that it has instances for. Word, meaning like a number, just by the way, word kind of being the same thing as integer. Well, no, it's not. But it's a number like integer, and so these all kind of make sense. Like the idea of generating a random in between 1 and 5. 1 can also be a float. Same with 5 can be a float. Actually, in this case, if 1 is a float, if A here is a float, then we know by the laws of type signatures that this other A must also be a float, because they must be the same type. And so, if we have 1.0, we can generate a random number between 1.0 and 5.0. We can generate a random number between 1 and 5. And each of them have their own specific implementation based on the type. Same with double. But interestingly, I just learned this, and this is actually what kind of inspired me to create to create this video, was the car type class. And you can actually see my results up here. I just played around with it very quickly and found out I can generate a random character. I just give it a range, right? So, if, let's say the range, just to illustrate here, if the range was not really a range at all, it was like A and B, this is not going to be very exciting. It's just going to give us something in that range of letters. And I imagine under the hood what they're doing is they're using, I think it's car, or no, it's the other one. Well, you would do car of 97, I believe. So not car. Import data.car. Ah, yes. I don't know how to remember that, honestly. But yeah, so I believe what it's doing is converting to this, and then just checking, the ASCII to see if it's probably generating a random ASCII, and then converting it back to a character here. So again, just another example of using Haskell type classes to kind of create all instances of what might be a very useful type. And then this is the actual list here. But as you'll see, most of them are, well, these are all C types, which actually might be a good video in the future. But yeah. So, but that's really it. That's all there really is to say. Of course, now extrapolating our thinking on character to bool, in the sense that character is not a number, but we can still make a reasonable type instance for character. We can do the same for bool, and what do you know? let's just do it for the sake of being obvious. It is crazy, this output here. I could not imagine what's going to happen. Yeah. So, yeah, and that's all there is to say. I will not let myself ramble on anymore. Thank you for watching this video. Hope you enjoyed it. Hope you found that helpful. But again, just this is definitely going to be a better resource if you are interested in getting deep into how random number generation actually works, or pseudo-random. So, bon voyage, happy coding, and a good night or morning, whatever the heck time it is for you. Bye.